Thank you for joining us today. I wanted to welcome you all to this webinar. I appreciate you all attending. My name is Paul Gagliardo. I'll be your moderator today. For those of you who were at ACE last week, I hope you all had a good and productive time. For those of you who weren't able to make it, make sure you talk to your manager about getting to go to one of these big water conferences. It's really worth it, even just to attend one of them, to see the big show on the exhibit hall and to hear the speakers. It's really worthwhile going. So today, this is the next in the series of webinars that Astera is sponsoring and putting on to talk about leak detection and remote Earth observation technologies and how it can assist water utilities in managing their assets. Traditional leak detection approaches are often localized, labor-intensive. It can make it difficult to assess priorities system-wide. As utilities seek broader data-driven strategies, satellite-based technology combined with AI analysis has emerged as a proven tool that can detect potable water leaks up to 10 feet underground and across large geographic areas of up to 1,000 square miles in a single satellite path. This webinar will discuss how these technologies are being integrated into utility operations to support system-wide monitoring, prioritize field investigations, and inform decision-making. We'll hear from the Jackson Energy Authority, who will share how they leverage this advanced technology to identify over 200 leaks that will save approximately 750,000 gallons a day of potable water. Deanna, can you switch the slides, please? So let me introduce today's speakers. My name is Paul Gagliardo, as I said. I've been in the water business for 35 years, now performing consulting work and host a podcast called The Water Entrepreneur. I'm a registered engineer, have a master's in public health, and I'll be today's moderator. We also have Jeremy Harwell, water systems engineer for the Jackson Energy Authority. And we have Patrick Day, territory sales manager at Astera. Next slide, please. So our main focus today will be on the Jackson Energy Authority. JEA will explore how they use the Astera technology to reduce non-revenue water in their system. After that, Astera will describe how L-band synthetic aperture radar works to identify likely leak locations in potable water systems, and also discuss how the use of AI improves the efficiency and the return on investment of leak detection programs. We will also explore how this innovative remote Earth observation technology supports the traditional boots on the ground field inspectors to increase their effectiveness in pinpointing leaks. Next slide, please. So Jeremy, thanks for joining us today. Can you tell us a little bit about the Jackson Energy Authority? You know, where is it? How many people do you serve? How many miles of pipe do you manage?
Sure. Sorry about that. I had to unmute. As you can see on the map there, we're kind of in the center of West Tennessee, in between Nashville, Memphis, and Jackson, Tennessee. We have a county population of roughly 100,000. We have 43,000 customer meters, maintain over 900 miles of pipe, 9 storage tanks, and we have 2 water treatment plants for a total capacity of 30 million gallons per day.
And what exactly is your role at JEA?
Management of day-to-day operations of our water system.
So you're on the distribution side, not on the treatment side, is that correct?
That's correct.
And do you, does JEA buy water from somebody else? Do you extract it from a lake or river and treat it yourself? What's your supply like?
No, we're blessed to have access to the Memphis Sands aquifer. We pump through roughly or approximately 18 wells located in 2 well fields, one for each treatment plant. The Memphis Sands consist of a thick layer of sands with a protective clay layer that provides a high quality source water. And we won a drinking water tasting contest here recently, so we're pretty excited about that.
Great. So you guys don't have to do a lot of treatment then. You got good quality water?
No, it's pretty simple process.
Great. Great.
No out.
That keeps your costs down as well, I'm sure.
It does.
So how much water do you deliver on an average day?
We average around 13 to 14 million gallons a day.
And is your peak like 2 times that? What's your peak delivery?
Our highest peak recently was, I think year before last during a winter storm, we saw service breaks, I think 22 million gallons.
Oh, wow. And do you know, you calculate non-revenue water and keep track of that? And if so, what's your non-revenue water level?
We do. Over the last 10 years, we've probably hovered around 25%. Several years ago, we started implementing AMI, which reduced it down to the low 20s. And now it looks like we've reduced that again since utilizing Astera.
Does the state have any kind of mandatory goals for non-revenue water? Some states do. I know California does. I think Texas does. Do you guys in Tennessee have any of that?
We do. We have to provide an annual information report to our comptroller using AWWA audit methodology. State considers anything greater than 40% water loss to be excessive, and they look for a less than 20% non-revenue water of your operating costs.
And I'm not sure how old your system is. I mean, do you have a lot of pipes that are maybe over 50 years old, or is your system pretty new?
No, we have some pushing probably 120 years now.
Cool. You don't have any wooden pipe, do you?
Not anymore. I think they pulled the last of that out maybe back during the 80s.
So what kind of material is it? Mainly cast iron? Do you guys use plastic? What's your material?
Inside the city limits or urban developments, we only allow ductile iron. We have a lot of cast iron in our old established areas or older areas, and then we've got a lot of PVC on our rural areas. A lot of systems we've not taking over; they've come to us, and we've assumed their responsibility. So,
and what challenges were you looking to resolve when you decided to develop a proactive leak detection program? Was it purely to reduce your non-revenue water? Was it a financial thing? What was the main driver?
A little bit of both. I wouldn't say either were the dominant drivers per se, because our non-revenue water and overall water loss was fairly reasonable to start with, but it did have a component of cost savings. Everybody in the water industry these days looking for where you can pull or save more money, but also preventative measure to prevent, your big water main breaks at 3 a.m. in the morning where you've got a road that caves in, just to prevent not only from a cost benefit, but from our guys being out in the mornings, being called for emergencies, and more than anything, probably the community's opinion of JEA.
The public perception piece is extremely important, and I'm glad to hear you guys are, kind of taking that to heart. I think it's really important to make sure that the public believes in the institution and believes they're doing the right thing. What role did you play in selecting Astera and developing this program? Was that part of your job, or is that somebody else?
It was part of mine. I'd heard of the satellite leak detection several times, but never really paid much attention to it. And my senior VP came to me one day and just asked me to investigate Astera. So I looked at Astera, some other options out there, followed up with some references, and everything pointed to Astera providing a quality service with results. So.
I wanted to ask you one question about terrain. I'm looking at your map there. You guys are you're not very mountainous, are you? Are you hilly area? I'm curious because I'm wondering how the Astera program works in different terrain kind of areas.
We have some rolling hills, but for the most part, we're fairly flat.
Okay. The name of your organization is the Jackson Energy Authority. There's no water in your title, your organization's title. So you're a multi-utility organization. I'm just kind of curious if, like for example, is there any overlap? Do you guys use the same, meters for your electricity and same meter manufacturer for your electricity and for your water? Do you use the same software packages? I'm just kind of curious how siloed the different utility functions are in your organization.
We're more siloed than I would like, but there's a lot of benefits to being a multi-utility provider. We offer electric, natural gas, water, wastewater, and telecom all under one roof. Of course, we do use the same software, same SCADA system, same AMI system, which is a huge benefit. Downside of that is it's not always the best thing for every division, but we try to make sure that it works for all. Cross-reporting issues, for instance, gas and water main leaks, debris on power lines, sanitary sewer overflows. It's just more, if somebody from the city sees something, they might not know what they're looking at or may not just feel it's their obligation to call it in. However, if one of our guys sees the same thing, they're definitely going to call it in. So that's a benefit. Conflict reviews and corridor planning, that's a huge benefit. Coordination for inspection and approvals of plans and projects. Permitting, we can have a multi-utility project and only have to receive one permit. I'm sure everyone loves to request for ARAPs and environmental reviews.
Right.
One recently, we had the national disaster in Tennessee for the winter storm, the ice storm that came through this year, and it's so much easier to report all at once than 5 different reports.
Great, thanks. So let's move on now to Astera. So, next slide, please. Patrick, can you give the listeners the kind of the basics on how the satellite assisted leak detection program works? What are the steps in the process?
All right, I certainly will. Thank you, Paul. And Jeremy, I appreciate you providing full profile and some background on your system. And also a thank you for everyone that has joined us this morning. The process is interesting. Our origin story at Astera really starts with the commission to go find water on Mars, on the red planet. And we were successful in doing so. And with that, every strong aerospace success hopefully finds its way to commercialization so that it can continue to be, a benefit to those of us left back here on Earth. And that is the way it started. So we are really relying on a technology that involves these three critical components you see on the slide now. It's first off the view, right? Satellite-based equipment. The sensor that's very special equipment. We are utilizing synthetic aperture radar, and with that, it gives us the incredible ability with very long wavelengths to penetrate the surface of the earth down to 10 feet in even clay soils. I'm based here in Georgia, so certainly very tight soil structures. We have gotten really, really good results. And if you've got a more open, sandy, rocky structure, then it lends itself to maybe even higher performance. And then the third component is the analysis. And this is kind of where our proprietary algorithms and, of course, the AI learning takes place on a continuous basis to refine this tool so that it gets better and better at detection and a much higher, hit rate for what's confirmed from those detected, what we call points of interest. So let me back up real quick on the view. The really cool thing about being able to image your water system from 400 miles up, we can do it in typically one fail pass, and if not, it's a couple of passes with the satellite. But what it would yield for you in 3 to 4 weeks turnaround is a snapshot of active leaks that we have detected across your entire system. So with that, you can do a lot, drive your own resources, incorporate a partnership with us supplying what we call boots on the ground to assist in investigation. But at the end of the day, time is on your side, and we feel like we're a fantastic complement to anything that you may or may not be doing already from a formal leak detection program. With that said, if you don't have a formal program at this point, what a great place to start just to assess the entire system with one snapshot from space. So when we get over to the sensor again, this synthetic aperture radar is quite unique. So the microwave pulses that this particular radar generates are both in a horizontal and vertical orientation, so that once those wavelengths penetrate the ground, we are able to interact with saturated soils. So it is specifically looking for either potable water or wastewater, depending on the algorithm that's used to scrub that data. And from there, we can detect and isolate water where it should not be, and that is outside of the pipe. The L-band frequency that we're utilizing gives us, again, those longer wavelengths that we need to penetrate down to that 10-foot depth. And then it also lends itself as we get into the analysis stage, because at this lower bandwidth, the properties of that water in the soil that we key on are those electrical properties, and that is strongly a dielectric coefficient and the conductivity. So through the backscatter echo of the microwave pulses that we are emitting from the satellite, we are able to analyze that backscatter in a way to actually type the water and distinguish potable water from wastewater, from salt water, and then ultimately groundwater. So that is where really our AI is improving daily, as it should, because it's taking every detection, every confirmation, and every repair into account to just get smarter on what it's looking for specifically.
Great, thanks, Patrick. Next slide, please. I think we kind of went through this, but Patrick, STERA's found over 200,000 leaks worldwide since you guys started doing this work in, I think, 2015. Maybe you can give us a little feedback on our information on kind of the triage of the program, because most utilities cannot afford, don't have the time or the manpower or the money to inspect every foot of pipe, every mile of pipe in their system. So how does the Astera system make the pinpointing work more efficient?
Paul, the system is the analogy I like to use. We cannot detect from space the needle in the haystack, because our view from a resolution perspective is typically 1.5 to 2 blocks. We're going to identify that a leak does truly exist, but it is in that area. And this represents roughly a 300-foot radius from that. So we can't detect the needle, but we certainly can tell you which to look. That is where we're able to get incredible efficiency. All those existing tools that a utility might have, or new tools that need to be introduced with a crew. And that is where that efficiency is gained. And just from the math that's projected here, we have seen on countless projects that there is a reduction from a full system scan down to about having to address only 10 to 15% of that total system.
Great. Next slide, please. So maybe you can give us some efficiency metrics comparing Astera-aided field inspection to traditional boots on the ground. So traditional boots on the ground is just sending out field inspectors to go from point A to point B without any real direction or real focus. So maybe you can go through some of the efficiency improvements.
What you see here is a comparison at the time of what you just identified, Paul, and that is acoustic leak detection crews that go and find leaks for a living. So they are really, really good. They use great equipment. They have developed the listening ear that those that do it truly understand. There's an art form still with this approach, but it is a critical aspect of being able to put an X on the ground and say, dig here for that repair. So from this study, over 2,000 projects for complete system surveys, and that is walking every mile of pipe within the distribution system. And of course, now we even bring the ability to look at wastewater leaks as well. And then, of course, at the time, that compared to about 880 projects. So from that data, you could just see the increase in efficiency, and we call it, a significant increase in leaks found per day and leaks found per mile.
Great. Next slide, please. So give us, the focus on JEA. How well did the program work during the 2 scans that you guys did last year and this year?
Paul, a comment on the second bullet point. So it does address over 200 total leaks were identified from those scans. Many of them, as you can imagine, were what we call in our software presentation overlapping points of interest. So again, verified yet again with a secondary scan that there is active leak detected, and that can increase your prioritization of where you're going to send resources. From that, you can see 82 utility side and 129 customer side leaks. Now, we certainly understand in our metrics and the ROI data that's returned in our presentation software interface that the utility side is most critical, but you must understand from space we cannot see your pipe network. Your pipe network is not introduced to us until we start looking at correlations after the scans are completed and we're going through the analysis process. And that would obviously come to us through you offering up any and all GIS layers that you have, so that we will, again, create high priority, but also helps confirm that the algorithms are doing their job by assessing potable water within 10, 15, depending on our threshold, proximity to a line. From that estimated 250 million gallons annualized recovered. And Jeremy may be able to speak to that as we wrap up here, but we feel like this was a tremendous success. We're looking at 3.5 leaks per day. So that productivity and really, you know, what we're offering here through this tool is incredible efficiency and visibility. And then 3.4 leaks per mile inspected. And that goes back and matches perfectly with kind of the metrics that were derived through the study from 2023 on the preceding slide.
Great, thanks, Patrick. Next slide, please. So, Jeremy, tell us how your organization was able to leverage the data that provided by Astera. I know Astera provides a dashboard to show you where the leaks are. Some utilities, go out immediately, generate work orders, and try to fix the leaks as soon as possible, depending on their priority levels, how bad the pinpointing crews think they are. What was your process after the crews came out and pinpointed the leaks? From internally, what was your work order process? I think you're on mute, Jeremy.
Can you hear me now?
There we go.
We chose to use Astera's subcontractor, boots on the ground, for the physical leak detection. And it was a very wise decision, well worth its money. We also chose to send out 2 of our distribution employees with them because sometimes you have to, uncover meters or valve boxes. They're familiar with the system, so they know exactly what to look for. And so that saves the boots on the ground a lot of time when they're investigating the potential leaks. And we was able to investigate, I think Eric, correct me if I'm wrong, but maybe 10% of the points of interest, which was way more than we initially, our initial goal was. And the guys were pretty impressive with McCreed and Kim. Is it Kim and Creed? McCreed and Kim.
McKim and Creed.
Yeah, McKim and Creed. Don't tell them I did that. But within the first 3 or 4 days, they found a rather large leak in a main corridor through Jackson. Is actually a state right of way, as is this one right here in the photo. And the McCreed and Kim employee said, your guys can dig this now. And I said, are you sure you want to start with this one? I said, you want to try something smaller first? I said, because if my guys go out here and they dig in this state right away and there's not a leak there, I said, they're not going to trust you the rest of the project. They went out there and dug it up that night, and sure enough, it was within a few feet of where they pointed. So it was a huge success there. Our guys fully bought in from then on. I hate to think about what would have happened if it went the other way, but fortunately for us, it did not.
So I'm curious, of all the leaks, a lot of them are on the customer side. I'm going to ask you about that in a second, but do you think that most of the water loss was, say, from this one big leak, or do you think, it was death by 1,000 cuts, that you had a lot of little leaks that were causing more problems?
You want to find your larger leaks because that's a lot of bang for your buck, but really it's death by 1,000 cuts. They add up. All the little leaks add up. So.
Yeah. And on the customer side leaks, I know some utilities have programs where if a customer identifies a leak on their property and they fix it, and then they can kind of show that there's a difference in the usage rates, that the utility does provide them some relief. Does JEA have any kind of program like that?
We do. I believe it's once per year. You're able to submit for a plumbing leak or some sort, and we'll pretty much waive your bill for that month.
Okay. And are you able to, quantify, through any of your meter readings, a reduction in water loss based on the Aster program, or money savings? Are you able to quantify the value proposition from the program?
Yes, I haven't quantified the exact water loss numbers to date. That's going to be a little, we got other things going on, so it's going to be hard to attribute what was to Aster, but there was a big drop this year. The curve, our linear curve's been downward, which is a good trend for us, but it steepened up this past year. So that's a good indicator that Aster paid off, basically. From a cost saving standpoint, based on the leaks we've repaired to date, and I think we repaired all the large ones and most of the small ones to my knowledge. But that is let me pull my numbers up. It's roughly just it's $200,000 a year savings in just treatment costs.
Wow.
If you want to be conservative with that number, I would feel 100% confident in that's $200,000 every 2 years, which is payback. It's pretty much payback almost for our contract with Aster, if not more. And that's just in treatment costs alone, not to mention the revenue opportunity. We chose to include that in our overall analysis just because it's lost capacity. So at some point you have to, build new plants, new wells, new pumps, install new pumps when you get to a certain capacity. So that water loss is eating up that capacity. We also looked at maintenance savings for being proactive versus reactive. And in the repairs, considering all the repairs we made, we estimated that to be over $500,000. And
Great. Does your organization do they expect I'll just generically call it an ROI, return on investment report, after you try these new innovative technologies? Is that something that your board or your management team is looking for at the end of the day? Or how do you document this performance? What's your game plan there?
we did, and I'm sure my senior VP will share it with our board. We're ran by or overseen by a board of 6 members, but we estimated the rate of return at 7 months on this project.
Wow, that's fabulous. And so what kind of advice would you give to other organizations that are looking to reduce their non-revenue water and to start a proactive program?
I'd highly recommend Aster. We've never had a true leak testing program here at JA. So this enabled us to get our feet wet at a low cost, and we piggybacked with McCreed and Kim. And actually, we're going to purchase the equipment they were using this fiscal year to start our own program internally. So,
great, fabulous, thank you. Next slide, please. There we go. So that's kind of the end of the presentation part of the webinar. If you want more information, you can certainly contact Patrick or Jeremy. Their contact information is shown on the slide. And I know Aster information is there as well. So now we'll go to a Q&A. And there's one question. Patrick, you had mentioned that Aster can identify wastewater leaks, exfiltration. Can you maybe expound a little bit upon that?
I can, Paul. Thank you. Yeah, well, you said the magic word, right? We don't look inside the pipe. We don't see pipes when we're conducting these scans from space. But what we do see is the ability to ID or wastewater as opposed to surrounding groundwater that exfiltrated that pipe. Of course, we've had good success just with gravity collection systems, but when we get into force mains, then even better results, as you might imagine. So there was a question I do see here, how is that possible? And again, it comes back to having a specific algorithm that is slightly different in what it is looking for as opposed to the one we're using for treated potable water. And the dielectric coefficient for salt water versus groundwater versus treated water versus distilled water is all different. And what we're able to do in that L-band radar frequency, that 1 to 2 gigahertz, is differentiate all of those and identify them accurately.
Great, thanks. And I'm curious, and I'm going to ask both Jeremy and Patrick to respond to this. Patrick, did you find that more leaks were found in urban areas, and I'm not sure if Jackson is considered urban or not, or rural areas, and like leaks per mile? I'm just kind of curious as to, I guess the generic question is, does the system work better or any different in rural areas versus urban areas? And Patrick, I'll ask you the same thing after Jeremy makes a comment.
I think it's hand down more. You get more per mile in your urban areas. You just have more pipe, and typically your older pipe. For us, anyways, it's our cast iron, which is one of our largest contributors.
And Patrick, any difference in performance?
Paul, collectively, we have not seen much fall off when we get into urban settings. We've got great data with leaks detected downtown Philly, parts of New York. We're growing that list. I think it's probably too early to tell, for me to be able to say that there is a quantitative drop off in what we're able to see from 400 miles above. But again, these satellite scans are coming in at an angle, and again, we have been able to detect leaks even within skylines.
Interesting. And how about like rain, snow, sleet and hail? You're as good as the postman. Do you always deliver?
The beauty with the L-band, that long wavelength, is that it is able to cut through cloud, vegetation, asphalt, a lot of structures on the ground without any issue. I would say that when it comes to severe storm events, if we've had 3 or 4 solid days of a saturating rain, we would probably want to certainly postpone, that particular scan. And we've got the ability to react and do that and work with the utility to time it where the conditions are absolutely optimal. And
Jeremy, I'm curious, do you see yourself using the maps, where you found leaks? Because I know that leaks in systems are not evenly distributed throughout a system. They tend to be clustered in certain areas. So I'm curious if you're using this information to help inform your asset management program and maybe your pipe replacement program or any other operational changes. Are you able to use this data for other purposes other than the immediate fixing of leaks?
Absolutely. I'm excited to add this into our prioritization algorithm or regressional analysis, AI these days, for instance. But it gave us a lot of data points to enter into our prioritization for what pipes we rehab first.
And so we did have a question. I know this is touchy, but if you feel comfortable answering it, Jeremy, there's a couple of questions about kind of what was the cost for a service. I know you had mentioned that you're looking at a 7-month return on investment. Was that just on the cost of production savings, or was that on all of the savings that you calculated?
That was anything. It's been a minute since I calculated that, but that was based on anything that was almost immediate, that was justifiably almost an immediate savings. So like the $140,000 a year, I think that was based on, initially I had it at $140,000 a year savings from just treatment costs. Well, that turned out to be $200,000. So really that payback is lower than even the 7 months, accounting for the corrections.
And I'm curious, what was the procurement process? Did you put something out to bid? Did you sole source it? How did that work?
We were able to pitch our board sole sourcing this based on state statutes and regulations. Just like you would any engineering, it's a specialized service. So we sole sourced it to Astera after doing our research.
Great. And I'm curious as to where you mentioned one of your VPs kind of identified Astera as a potential partner, contractor. I'm curious as to do you know where he or she learned about it? Through the literature, going to conferences. How did your team kind of first get exposed to this technology?
I believe they were at a managerial conference, maybe in Texas.
Okay. Yeah, I'm just trying to, a lot of people I started this conversation today about ACE, and it just goes to show you the value of going to the different conferences and things you can learn, and the value you can bring to your organization. So, that's all the questions that we've got. Again, feel free to reach out to Astera directly, or to Jeremy or Patrick. They can answer any of the questions that you've got. Certainly, if you have any questions for me, you can find me through Astera. But I want to thank you all for attending. Really appreciate it. I think we're going to be putting on another show in about a month, so feel free to join us then. So thank you very much. I appreciate it.